So this engine is a petrol engine, or also known as spark ignition engine. So in this engine, the air plus fuel get mixed in the carburetor, and that is sucked into the engine cylinder of one of the first process, that is the suction process. Engine में 4 process होता है: suction, then followed by compression, then the ignition, that's a power stroke. The last one is the exhaust process. So during the exhaust process, burnt gases are pushed out of the engine cylinder. Okay. So in the process, if it is a 2-stroke engine, in order to complete 4 processes, it takes only 2 revolutions. Like in 360 degrees, we should be able to have this. No? So 90 degrees, one process. Okay. In the case of 4-stroke engine, it takes 2 revolutions. That means not 360, 360 to 2. So now, so far आपको कोई डाउट्स है क्या इसमें? हेलो,
सर
कोई डाउट्स है आप तक इंजन में? I think what is that we discussed so far? Do you have any doubts on that? Well, if no doubts, we'll go ahead with that. So working principle. So all the processes, that's a total sequence of activities like a suction, compression, followed by, what is that? No, these are the 4 processes. In this process, it's a 4-stroke engine. In the 4-stroke engine, you have a valves here, right? In the first picture, you can see the crankshaft is rotating in the clockwise direction, and whereas piston moves up and down. So when in the first process, that's a suction process, also known as intake process. Usme piston, it just starts coming down. At that particular moment, when the piston turns, moving down, it starts moving down, then inlet valve opens. Through the inlet passage, the air fuel mixture gets into the engine cylinder. So this continues until it reaches the bottom dead center. So बाद में the second process starts. Once a piston, downward moving piston reaches the BDC, bottom dead center, there's a time wherein crankshaft starts moving upwards. So it just starts, piston starts moving up, compressing the charge, air fuel mixture in the case of petrol engine. In the case of diesel engine, it's only air gets compressed. Now piston is moving in the upward direction. Is that right? It's moving upward direction. And also observe these 2 walls are in a closed position. Both the walls अभी closed position में रहता है. So walls का normally position क्या होता है? Normally they are closed. कोई wall open नहीं होता है. So sequence के अनुसार हमारा mechanism activate करता है इसका. So through valve actuating mechanism. So what is the duration of that crank angle? We have to keep intake valve open or exhaust valve open. That is decided by what is called the timing gears. Okay. So right now, during the compression process, one second please. Sorry, urgent call. Well, there's a second process is the compression process. The first section, the piston moves down until the bottom dead center. So at that point of time, it is the suction process. When it reaches the BDC, the piston starts moving upward. So that's the moment wherein the compression process starts. It goes when it's close to top dead center, then the fuel injection takes place. That's in the third picture. Fuel injection or the spark takes place. Okay. So observe दोनों valves closed position में है. So explosion हो जाता है. Piston starts moving down now. This is the time, this is the stroke or the process which gives you the energy, the power. So that extra energy, whatever is getting now, is stored in the flywheel. In the flywheel, one flywheel, I think I just shown you the components. Okay. So this process continues until BDC, up to bottom dead center. So at that particular instant, when it reaches the BDC and changes its direction of movement from bottom to top again. So this is the one, fourth one. That's the moment this exhaust valve opens. Exhaust valve opens, and that continue to remain open until the piston reaches top. So because of pressure inside the cylinder and outside pressure, there are two differences now. Now atmospheric pressure is at atmospheric pressure only, and inside the cylinder you get many times more than the atmospheric pressure. So whenever what happens, the pressure difference occurs, a gas which is there inside the engine cylinder rushes out due to high pressure inside. And when the pressure between the inside cylinder and atmosphere equals, at that particular instant, there will be small amount of the burnt gases are remaining in the cylinder. So this upward moving piston forces it out or it flushes it out, thus ensuring maximum gases are going out of the engine cylinder. Maybe in some remote corner, we'll be having a very small traces left in. So thus that engine cylinder now ready to accept fresh charge. The fourth process, it's when exhaust process, when piston reaches its uppermost limit, that's the top dead center. So that's the time wherein the charge is ready and it starts moving down. It commences the next cycle. So these four processes put together, when it completes the crankshaft totally, all the process, it's called working cycle. Okay. So in the case of four-stroke engine, you can see the four events are completed. Four events means suction, compression. In the figure, it is shown intake, compression, power, and exhaust. Totally four processes happens in 2 revolutions of the crankshaft. That is 360 into 2. That is 720 degrees crank rotation. That means in order to complete one process, a crankshaft has to rotate by 180 degrees of rotation. So this is the little more insight into, same arrangement, but it is a petrol engine. So earlier is the injection, there's a CI engine, compression ignition engine. Now you can see this is what is this? It's a petrol engine. So in the petrol engine, invariably we have a spark plug. So you can see in the combustion chamber, inside this, do the intake, you'll be having only air fuel mixture. The fuel is the red dots shown and air is the blue dots. Otherwise, the same operation. When both the valves are closed in the compression process, explosion, just about rotate, the piston starts moving down, the spark generated, thus there will be explosion, enormous amount of explosion. So thus it just comes down. So next is two-stroke engine. So notice the difference. two-stroke engine, you can see construction is very simple. The first of all, physical construction. See, less number of moving parts. What are the moving parts we have? Piston, connecting rod, and crankshaft. Only that much. Only three moving components there in the two-stroke engine now. Okay. If you see four-stroke engine, piston, connecting rod, and crankshaft. Three plus two valves here and their actuating mechanisms. So all put together will be more number of components. You know. So in the case of two-stroke engine, there is a reason why for the same power, the engine is very compact in the case of two-stroke engine because of less number of components, less number of moving components. And hence, this is the one which is the better suitable for high power, less weight. That means a power to weight ratio is good in this case. You know, more power and less weight, and hence power ratio is higher. So that's the reason why we use most of the sports cars or sports bikes, even the boats, you know, and some cases we use, but very rarely we come across. For drones also we use at times a small, in a palm top engine, very small engine we'll be using for the drones too. So now we are converting into engines to what is it called a battery operated, small power plant. So now look at this. Now, so who is going to let the fuel in, or air fuel coming into the engine cylinder? This is the particularly what is that example shown is a petrol engine. The title goes two-stroke cycle engine. This is called as a petrol engine or spark ignition engine. So in two-stroke cycle engines, the whole sequence of activities, all the four activities completes in only two movements. One upward movement, one downward movement of the piston. That means totally 360 degrees rotation only. You will be completing all the four processes. Okay. How? There are certain processes happening simultaneously. So for example, the downward moving piston, maybe in the first initially, it is sucking in air and air fuel mixture into this cylinder on the top. And before that, commencement, you can see initially it just moves down. Okay. So when it is moving down, it creates a lot of suction inside the cylinder, between the space between the head of the cylinder and the cylinder head, the whatever hollow space, it's just moving down. So it will be creating a small vacuum, partial vacuum inside the cylinder. So you can see there are two ports. One, this is the port, and another port is here. You can notice here, this is one port, and you have one more port here. So when you can see right now, both the ports are closed by piston itself. This port as well as this port, both are closed. So this is the exhaust port. This is the exhaust port here. And you can see the air fuel mixture enters through this port here, one more port, but it's not directly open to the cylinder. So this port opens, and during the upward movement of the piston, exhaust process, upward movement of the piston. So then what happens? The partial vacuum, this is called as, this entire cylinder and crankcase are airtight. This entire thing is airtight. There's no leakage as such. So this air and air fuel mixture drawn into the engine cylinder during the upward movement of the piston, during the exhaust process itself. So that means this entire cylinder now filled in with the air fuel mixture. During the expansion, when the piston starts moving down, because of the explosion, so inside the crankcase already here, the air fuel mixture is present. So now that this valve, this passage closes and the air passes through this transfer port. From here, air enters because the downward moving piston pressurizes inside the crankcase. So that is now moving up. The moment this downward moving piston reaches this level, this uncovers it. And you can see, notice the piston shape, the piston head is like this. Piston head is like this. So this is the cylinder. This is the enlarged one. So when this opens here, you can see, otherwise one side is small opening because the cut. And from the transport, the gases enters like this because it creates suction in the top of the piston. Suction is vacuum, partial vacuum. Thus, the fuel and air mixture enters into the cylinder. So that continues until the other side of the piston. Here, this is the one. So until this opens this, opens this. So now this entry happens here. By the time this reaches here, that entire thing gets in. See that there's a difference here. And the piston coming here, this is the distance. Okay. So this much when just moves down. Now this is filled with, maybe in the other sketch I'll just show you. So this is what is happening here. In the downstroke, in the second picture, you can see the fuel now enters into the air fuel mixture into cylinder. And maybe some fuel also gets exhausted through this port opening. But is the exaggeration here in an actual cylinder. So it will be very close to this. Okay, very close to this. I'll just show you that in the laboratory. So in this arrangement, there will be one more extra port, what is called as a transfer port. The air fuel mixture is transferred from the crankcase to the engine cylinder during the downward movement of the piston during the expansion stroke or the power stroke. So thus that enters. Now the crankshaft rotates in the clockwise direction. Thus the crank moves upward, right? So this is how it just coming in here. It just goes up, right? And this will be moving upwards, thus compressing the air fuel mixture now. So in the upward travel, this also closes this port, exhaust port, as well as the transfer port. So this moves up, and when it reaches here happens the spark, thus initiating another movement of the piston. This is how it just happens. So the differences between two-stroke engine and four-stroke engine with a petrol or diesel engine are simple. One is in the four-stroke engine, we'll have a comparison statement in the next slide you can see. So this is the little extra kind of thing, you can see how these things are happening. Two ports are shown here only. One is intake here, a different, just like a motorbike engine. You have two ports, one port here and one port here, different arrangements. And you can see transfer port is here. This is the transfer port. Okay. This is the transfer port now. This is a different arrangement for the same sketch. And this is the graphical arrangement. You can just show that. Yeah. Now, comparison between two-stroke and four-stroke. So, what is the first one? The number of revolutions needed or number of rotations of the crankshaft. In the case of four-stroke engine, it's a 2 rotations for 1 power stroke. In the case of two-stroke engine, for only 1 rotation is needed per power stroke. So that means in every rotation you have 1 power stroke in the case of two-stroke engine. For every 2 rotations of the crankshaft, you have only 1 power stroke in the case of 4-stroke engine. So valves, in the case of 4-stroke engine, you have 2 valves. One is the exhaust valve, other one is intake valve. Whereas in the 2-stroke engines, in place of there are no valves, instead of valves, we'll be having ports. So in the case of 4-stroke engine, the crankcase is open to the atmospheric pressure. The crankcase is open to the atmospheric pressure. That means it's not closed. It's not totally airtight. Whereas in the case of a 2-stroke engine, crankcase is fully closed as well as it is airtight. So no leakages are permitted. If there is any leakage, we'll be losing what is called the air-fuel mixture. That means the power loss happens if there is any leakage. So the next point is the top of the piston compresses the charge. Top of the only in the compressed stroke, it only compresses the charge. So in the case of 2-stroke engine, the both upper side of the piston as well as lower bottom side of the piston both compresses, isn't it? So when the piston moving down, the charge sucked into the crankcase is being pressurized. Thus the moment the transfer port opens, so the air-fuel mixture from the bottom, the crankcase, just gets into the engine cylinder inside. So when the piston starts moving up, water previously sucked into the engine cylinder, that is compressed. So both these sides, during the expansion process also, that compresses the air-fuel mixture inside the thing. Inside, and the piston moving upward, that compresses the charge inside the cylinder above the piston. Yeah, in the case of 4-stroke engines, the size of the flywheel is larger because for every 2 revolutions you have 1 power stroke. That's the energy you get it, power you get it for every 2 revolutions once, and hence there's a lot of time gap. Whereas in the case of 2-stroke engine, for every rotation you have 1 power stroke. Hence, you need to have a smaller flywheel. So in the fuel consumption, or the combustion nature. In the case of 4-stroke engine, complete combustion of fuel occurs because we'll be having sufficient time for fuel to burn completely. Whereas in the case of 2-stroke engine, some fuel escapes through the exhaust gases. So to that extent, we'll be losing. So that means the entire air-fuel mixture is not burnt inside the 2-stroke engine. There will be small losses. That's the reason why 4-stroke engines are polluting less, whereas 2-stroke engine pollution is also higher. Further, we'll be seeing that. So in the case of 4-stroke engine, weight of the engine per HP is high because the larger flywheel and more number of moving components. So whereas in the case of 2-stroke engine, the engine size is smaller and also less number of moving components, and hence it's going to be very compact, and hence it will be having a better power ratio, power to weight ratio, and as well as power to size ratio. So it will be better. So when compared to the thermal efficiency is the fuel burnt inside to the energy obtained. And we have a better fuel burning inside the engine cylinder, and hence the thermal efficiency, that's the output divided by input, is normal efficiency. Particularly when you talk about thermal efficiency, the energy supplied, is at the bottom and energy converted. So that is the efficiency. Normally, we'll be having anything between 35 to 38% thermal efficiency of the engines. So 4-stroke engine will have a better thermal efficiency, whereas in the case of 2-stroke engine, it is low because there will be loss of fuel. And in the case of 4-stroke engine, torque produced is even. So in the case of torque means the power to rotate the shaft. So it is In the case of a two-stroke engine, it is less even. Yeah, this already I think we just had it. For a given weight, engine would give only half the power of two-stroke engine. That means power to weight ratio is lower in the case of four-stroke engine, whereas in the two-stroke engine it is better. In the case of like speed, that's what in the beginning of this session only I was just talking about, having a better uh, power for the weight ratio, and hence these engines are mostly used for racing cars, you know, the high speed, like high rotation, RPM also very high, and hence mostly for motorbikes will be using it. So next is right. So the direction of operation, you cannot reverse the crankshaft rotation in the case of four-stroke engine because the arrangement is fixed, that valve operation, etc. Because of these extra attachments of the mechanical arrangement, you cannot run that in the opposite direction. Whereas two-stroke engines can be run either direction, clockwise crankshaft or anti-clockwise. You know, so this is possible with this. Those who have got older version, that are two-stroke Java motorbikes or the HD motorbike, you can have that engine started in both these directions. Okay, that I'll be showing you in the university. So some more features of diesel engines. So I think in the very beginning of these classes, we did discuss about the compression ratio. That means to the pressure which we are going to compress the air inside the cylinder. In the CA engines, there's a diesel engines, we'll be having compression is very high. We'll be having 14:1. That means the inside the pressure, you are going to raise it by 14 times the atmosphere. So to 22 times in the cylinder. That means the air becomes very hot in the diesel engines or compression ignition engines. So further, during the compression stroke, what is the pressure inside the cylinder? Anything around 30 to 45 kgs per square centimeter. That's for area, you know. And temperatures. This is the operating temperature. Operating temperature of CA engine is around 600 degrees centigrade. So beyond which we are not allowing it to go. We are using some other arrangement. There's one system I think we did discuss about it. What is called as cooling system. The engine cooling system will be using it such that this operating temperature will not go beyond the 600 degrees centigrade in the cylinder. But at the time of the explosion, that's much more higher, at least 3 times higher than the normal working temperature of the AC engine, particularly the CA engine or the diesel engine. So at the end of compressed stroke, fuel is injected into the cylinder through injectors. Injectors are not like our doctor gives the engine syringe kind of thing. So the doctor syringe will be having a slightly higher pressure than our blood BP, you know, when we are just blood pressure. So when you are injecting the fuel into our body. So whereas in the case of the injectors which we use, different types of injectors we have, a nozzle type, you know, the different types. So normally in the IC engines we'll be using pintle nozzle. What is that? It will be having a more than one hole, a small minor hole. And the pressure at which we force this fuel pass through that narrow, small nozzle, you know, passage, that makes this fuel drops break into, it's called atomization, very fine micro particles, such that it gets penetrated. The one small droplet is now broken into several micro droplets and spread across like the mist kind of thing, you know, several particles just spreads across, and the simultaneously 3 jets will emerge. The fuel jets will be emerging. So inside there's a fuel injector. Before that, we have what is called a fuel pump. and this fuel pump gets the drive from the crankshaft itself. There's a mechanism again. So the compression inside is 22 atmospheres. What is that? 32, 45 kg per square centimeter is the inside. And at that pressure, if you want to gain the entry, then what is the pressure is needed? It's definitely much higher. So anything between 3 to 4 times or 5 times higher pressure, we are injecting it, such that fuel can comfortably penetrate into the compressed air inside the engine cylinder. Okay, such that it's something like opposing force inside the cylinder. Already it is having about 30 to 45 kg per square centimeter pressure. So that becomes almost like a solid wall for the normal entry. So unless otherwise, we have highest pressure, close to 4 to 5 times higher pressure, we are injecting the fuel so that penetrates into, in a fine mist, and the temperature, whatever that air compressor has around something like 1200 degrees centigrade, 1300 or 14, it depends on the compression. At the 14:1 compression ratio, the temperature may be around anything around 900 degrees centigrade. As the compression ratio increases, the temperature also correspondingly increases. So at that instant, the first fuel particle enters into the compressed air that catches the fire. And this molecule, which is burning, induces that ignition to the other fuel particles, just gaining entry. So thus, all the fuel molecules, when they follow, they all instantly starts burning. Thus, it's a sort of explosion occurs inside the cylinder, and that spreads across. And because everything is curvature and other things are given to the engine cylinder and head, so that entire force which is being generated now acts